we only work with radians for trig functions. So anytime you are using your calculator for anything trig related, make sure you are in radian mode. Otherwise, your answers will be incorrect. And then I wanted to review notation. So if you see sine squared x, what does that mean? What's another way to write this? Okay, so that's sine of x squared. So what does sine x squared mean? Yeah, so this is just if they have something like this without parentheses, the x squared is the input into the sine function. So not getting those mixed up. And then so there's 3 different ways to include what looks like an exponent of -1. And I want to make sure you understand the difference in those 3. So what would the first one, what would be a way to rewrite the first one? 1 over sine of x, which is cosecant of x. And then what about the second one? Yep, sine of 1 over x. In parentheses or not, you wouldn't need them around the 1 over x. And then what does the last one mean? Dylan? Well, yeah, there is another way to rewrite it, but what does it mean? Like, how is it different from the first one? Because they're not the same. It is arcsine. It's the inverse of sine. So another way to write this, and you will see both notations. You will see it written as, this is sine inverse, or the inverse of sine of x. And then another way to write it is arcsine of x. Inverse of sine is not cosecant. Cosecant is the reciprocal of sine, and then inverse of sine is a different function. So they are different. They're not the same. All right, so that's just reviewing some notation with you. And then in example 1, I included a graph of sine of x, and what I would like you to do quickly is use what we know about graphing, being given a graph of f and graphing f prime, the derivative. I want you to graph, based on the graph of sine of x, what the graph of f prime would look like. And then try to think of what function would be the derivative of sine. So graph the derivative and see if it looks like the graph of any function you know, I guess is another way to phrase that. All right. Now, some of you might not have the graph drawn like within the correct range. That's fine, just getting the shape down, but any guesses as to what the derivative of sine is? Maybe you already know. Cosine of x. Okay, so I can tell you the derivative of sine of x is cosine of x, but with example 2, I want you to see why. Now, we're not going to go through a proof for, we could go through a similar proof for why the derivative of cosine of x is what it is. But this is a more lengthy proof. I just want you to see why. So is this something you're going to have to mimic? No. But just seeing why, and then we are going to be using these limits within our proof. These limits alone have their own separate proof, so we're not just going proof crazy today, but I want you to see at least somewhat a proof of sine of x. So we are going to prove that the derivative of sine of x is cosine of x using the definition of derivative, and that's the limit that we used in chapter 2. So we are going to find f prime of x using the limit as h approaches 0 of f of x plus h minus f of x, all divided by h, given that our f of x is sine of x. So we would have the limit as h approaches 0, f of x plus h would be plugging x plus h into the sine function, so it would be sine of x plus h minus f of x is sine of x all over h. And now remember, if I have sine of x plus h, it's not sine times x plus h. Sine is not something I can distribute. So this is where we are going to use a trig identity on this sheet. We are going to use, if you look under the addition and subtraction formulas, we're going to use the first one. So rather than having sine of x plus y, we have x plus h. But we're going to set it equal to this. We're going to use that in our proof. So I'm going to rewrite sine of x plus h using that trig identity. So that would be sine of x times cosine of h plus cosine of x times sine of h. And then we still have minus sine of x all over h. So I'm going to highlight what I had used as the trig identity. So sine of x plus h was equal to that using that addition formula. And then from here, I'm going to rearrange this a little bit. So notice so you have 3 terms in the numerator and 2 of them have sine of x. One of them does not. So I want to kind of pair those together. So I'm going to move the minus sine of x here. I'm just going to rearrange the top. So I have the limit as h approaches 0 of sine of x cosine of h minus sine of x, and then plus cosine of x sine of h. So just rearranging. And from here, I'm going to group the 2 terms that have sine of x in them together because I'm going to factor sine of x out of those 2 terms. So then I have cosine of x, sine of h is kind of its own term. And when I do this, I don't want to do too much in one step, but I'm not only going to factor sine of x out of here, but I'm also going to split this into 2 fractions. I'm going to have this all over h plus this all over h. We're going to be splitting this up a little bit. So I have the limit as h approaches 0 of, and factoring out the sine of x, And I'm left with cosine of h minus 1. And I'm writing that all over h. And then plus, I still have cosine of x, sine of h, all over h. And it's the limit of this whole thing. And now we're going to use some limit laws. So I'm going to split this even further. Notice for that first quantity, so I have sine of x times the cosine of h minus 1. I could have written that as sine of x times this whole fraction. So I can split that using limit laws into the limit of sine times the limit of this quantity. And then same thing for this one, I have cosine of x times sine of h. What I'm trying to do is separate what is in terms of x and what is in terms of h. So I'm going to have the sine of h over h as one quantity multiplied by the cosine of x, so I can split that into the limit of cosine times the limit of sine of h over h. Idea? Oh, when I split it, why don't I have to have the h? Because with fractions, like if I wrote, I'll just write this out, like this would be sine of x if I didn't write it as one fraction. So this is equal to this because when you multiply fractions, you multiply the numerators and the denominators. So the sign doesn't have to be over h because then if I multiplied it, I would have h squared. I'm pairing the h with this one because this is in terms of h, the sine of x is not. So that's why I'm splitting it up. Yep. So I'm going to split this into 4 different limits. So I have the limit as h approaches 0 of sine of x times the limit as h approaches 0 of my cosine of h minus 1 over h. So that's splitting that first fraction into 2 separate limits being multiplied together. And then I have plus the limit as h approaches 0 of cosine of x times the limit as h approaches 0 of sine of h over h. So why I split it this way, again, I was trying to split the x's and split the h's, but now I can actually find these limits, and like I said, we're using these 2 limit formulas I have above, but the limit as h approaches 0 of sine of x, there is no h in sine of x, meaning this limit is just equal to sine, because sine of x doesn't depend on h at all, so if h is approaching 0, sine of x is still sine of x. So this limit is just sine of x times this limit. I can use, and these are limits given in your book, you don't have to have them memorized, but this limit follows that second formula, that the limit as, they wrote it as theta approaches 0 of cosine of theta minus 1 over theta equals 0. So here the thetas are just h's. So this limit has proven to be 0, plus the limit as h approaches 0 of cosine of x is just cosine of x for the same reason that the limit of sine was just sine of x. And then the limit as h approaches 0 of sine of h over h follows this formula here. Limit as theta approaches 0 of sine of theta over theta is 1. So this limit is 1. So you end up with sine of x times 0, which is 0, plus cosine of x times 1, which is cosine of x. So your derivative is just cosine of x. Okay, that is a lot, but that shows you where the derivative of sine of x comes from using the definition we had. So all you need to know, because you're not going to find, anytime you have to find the derivative of sine, you're not going to do this. You need to know, and this is just memorization, derivative of sine of x is cosine of x. You just need to know that. Okay, but this shows you why. You won't need to like mimic or prove it, no. But I don't always like to just say, here's what it is, and you just go with it. I like you to at least see why. Okay, so on the back, there are 6 trig functions, sine, cosine, tangent, and their reciprocals. We cover derivatives of inverse trig functions later. So I wrote these in the Leibniz notation. So again, d dx is the derivative with respect to x of sine of x is cosine of x. We could go through a similar proof like we just did with cosine of x. I'm not going to, but we could. And that would show that the derivative of cosine is the opposite of sine of x. So it's not just sine of x, it's the opposite of sine of x. Okay, then derivative of tangent of x. I actually want to go through a proof of this one. It's much shorter and perhaps easier to understand. If I asked you to find the derivative of tangent of x, this means I'm finding the derivative of, and what's another way we can write tangent of x? So tangent of x is a quotient. We have a quotient rule to find derivatives. So you can use the quotient rule to find the derivative of tangent. Top function is sine of x. Bottom function is cosine of x. Derivative of the top, so derivative of sine of x is cosine of x. Derivative of the bottom, derivative of cosine, is the opposite of sine of x. And then we can apply the quotient rule. Now, I know I haven't passed the homework quizzes back. I haven't gotten them all yet. But some of you had flipped your terms on the top. The quotient rule is bottom times top prime first. And then minus top times bottom prime over the bottom squared. So it would be bottom times top prime would be cosine of x times cosine of x minus top times bottom prime is sine of x times the opposite of sine of x all over the bottom squared, so cosine of x squared, or cosine squared of x if you wanted to write it that way. So then if we simplify this, we would end up having cosine squared x minus, or actually it'd be plus, sine squared x over, and I'm going to write this now as cosine squared x. Well, these don't cancel. The top is 1, cosine squared plus sine squared is 1. 1 over cosine squared is secant squared x. So the derivative of tangent is secant squared x. So anytime you have to find the derivative of tangent, you do not have to do this. Again, I know this is kind of where the memorization comes in. You just need to know derivative of tangent is secant squared. If you forgot, you could find it this way, but don't do this every time because it's going to come out to be secant squared every time. So don't, just memorize that. And then we could go through similar proofs for these last 3. The reciprocal functions we could all write as quotients. But to give you the derivatives, the derivative of cosecant x is the opposite of cosecant x times cotangent x. So the derivative of cosecant is the opposite of cosecant x times cotangent x. The derivative of secant of x is secant x times tangent x. And the derivative of cotangent is the opposite of cosecant squared x. Derivatives of trig functions is memorization. Just knowing what they are. When you see sine, cosine, tangent come up the most. But when these come up, just being able to use them. Flashcards, memorize. It's just memorizing what they are. It's just knowing them. They're not given to you on the AP test. You just have to know them. For your quiz on Friday, you at least have to know the derivative of sine, cosine, tangent. For this Friday, at least sine, cosine, tangent you need to know. But as we move forward, AP tests, you have to know all of them. So, also I want to point out a helpful trick to know which ones are negative. Do you notice anything about which ones are negative? All of the ones that start with co something. So the derivative of cosine is opposite sign. Cosecant is opposite. Cotangent is opposite. So to remember which ones have an opposite or a negative in front. If it starts with co, it has a negative in front. All right, so I just have a couple of examples. Example 3, differentiate y equals x squared sine of x. What do you need other than the derivative of sine? What do you need to find the derivative of this function? Product rule. It is a product. So make sure you're using the product rule, not just taking the derivative of x squared times the derivative of sine. That would be incorrect. So the first function is x squared. Second is sine of x. So the derivative of the first, derivative of x squared is 2x. Derivative of sine of x is cosine of x. So then y prime will be first times derivative of the second, so x squared times cosine of x, plus, so with the product rule you add the terms, so really it doesn't matter which order you have the terms with product rule because they're being added, but second times first prime would be 2x times sine of x. And then you could just leave it if you were thinking of trying to simplify. I mean, they do have an x in common, not this x. You can't factor this x out. I see that sometimes. Don't do that. But they do have an x in common if you wanted to factor out an x and write it as x cosine x plus 2 sine of x. But you wouldn't have to do that. And that would be the derivative. For example 4, so this says to differentiate f of x. F of x is a quotient. I know we have 5 minutes. I want everybody to at least find the derivative of f of x. Part B says for what values does it have a horizontal tangent. You can go ahead and do that too, but at least find the derivative of f.
Oh.
Would this be the derivative non-simplified?
Yeah.
Okay.
Yeah.
And then from there,
Dalton, no. You can wait.
then how would you simplify this?
I'm just going to show that now.
Okay.
I just want to show everybody, but I'll explain it.
Is this alright? Oh, I got it right. Yeah, boy. Oh, I didn't do B.
Oh my gosh, I have it right so far. I'm sorry, no. Oh, this is really
All right, check up here. I do have the simplified version, but this could be what you had. You do not need the simplified version. I didn't answer all of part B, but you would find where the derivative is equal to 0.